Good morning. This is Schweitzer, and going to give you some answers to a couple of workbook problems involving mathematical relationships. Before I get too started on this, just a quick review that um, essentially because molecules are so small and their quantities are so large, we have a few ways we can measure the quantity of particles. One is just literally the numbers of them. So let's say atoms, or molecules, or ions. Again, it's more along the lines of just what is this thing? Um, Number of individuals. So this is the number of individuals. This can be shuffled back and forth to basically what's called moles. And mole is like a dozen. And this is the relationship right here. So anytime I have a number of items, let's say like atoms, okay, now again, we might deal with 10 or 12 atoms, but that's not realistic on a human level. So whenever I'm dealing with atoms, I want to flip this over to moles of atoms. I would get rid of atoms, and I would go to moles of atoms. This is like saying dozens of atoms. It's like how many, a mole is a package of things. So 1 mole is always equivalent to this relationship. This is just factor label 6.022 e to the 23rd. Okay, so we're always going to be using this equivalency to flip between either atoms to moles or moles to atoms. That's our equivalency. So I'm just going to go through a couple of different examples of these. I'm not going to do all of them. And if you'll find, as you do 1 or 2 of them, they're all kind of the same. All right, so with our equivalency in mind, all right, so I'm going to do this first one. I want to convert the following to moles. All right, so I'm going to go 3.011 e to the 23rd. Now again, hydrogen gas is a molecule. It looks like this. Okay, it's not necessarily an atom, it's a pair of atoms. All right, dot line. I'm going to go get rid of molecules. Now, if I inadvertently called it an atom, it really wouldn't matter. This is a mole. Now you notice, following all our factor label stuff here, this is molecules. This will cancel. I got to just put my equivalency in. 1 mole is equivalent to 6.022 e to the 23rd. And when I do this, I divide this number by this number, which is conveniently 0.5, and then I subtract my exponents to 0, e to the 0 power. So this is just, there we go, 0.5 moles. It's a half a mole. All right, next one, 9.995 e to the 24th. So I have more than 1 mole. 9.995 e to the 24th molecule. It wouldn't matter if it was an ion either. All right, and this is going to be a molecule because that's, well, technically that's a form of the unit. So it's a calling it a molecule might not be exactly right, but again, it doesn't particularly matter for what we're doing. But it's not a molecule. That's a form of the unit. So I'm going to call it a form of the unit. Formula unit. It's a piece of a bulk crystal. All right, get rid of formula unit and go to moles. All right, again, I'm doing the same process before, 6.022 e to the 23rd. We divide these two numbers, so 10 divided by 6 is a number a little bit bigger than 1, and then subtract off the 24 from 23, that's 1, and I'm going to get an answer here which is 16.5. Or it would be 1.65 e to the first. Okay. All right. Let's skip down to the bottom ones here. Show another example of this. Now in here, we're given moles. I'm going to find actual number of particles. So again, moles still measures number of particles, just like a dozen donuts still measures the number of donuts. 12 or 1 dozen, they both measure number of individuals. That's important as we go forward in chemistry. So 2.5 moles, dot line, get rid of moles, and this guy happens to be oxygen gas, which is a molecule. One mole is 6.022 e to the 23rd. Again, I'm just keeping track of my equivalency. Moles cancel, so 1 mole has to go on the bottom, this is on top, so I'm going to multiply by this now. And this is going to give me, now I have 2 sig figs here. We're going through some sig figs issues, so here we're at 2, I'm going to hold 2 sig figs. That's my smallest number of sig figs. It's 1.5 e to the 24th. And that would be molecules of oxygen gas. All right, 1 mole, well that's just going to be 6.022 e to the 23rd. 2.2 moles of lithium ions. Okay, so lithium has to be Li+1, which is fine. Okay, doesn't really matter. It's just a number of things. What this is here just doesn't matter. It could be 2.2 moles of donuts. It's just number of things. How many actual number of individuals are there? Well, let's do this. 2.2 e to the 20. Let's see here. Just 2.2, no e. Take that off there. All right, 2.2 moles. Get rid of moles. Go to ions, actual ions. 1 mole is equal to 6.022 e to the 23rd. Now don't just let your calculator do all the work. 2 times 6 is 12. So my answer is 12 e to the 23rd. This is my 12 e to the 23rd is an approximate answer. Or 1 point okay, well, let's redo that here. 12 e to the 23rd or 1.2 e to the 24th. So again, that's an approximation. I just took 2 times that. If I took 2.2, it's going to be a little bit bigger. The actual answer, as you plug it into your calculator, is going to be 1.32 e, all right, to the 24th. So keep in mind, you do not need your calculator here to get anything. If you're multiplying a number with an exponent and one that doesn't have one, then the exponent just stays the same, 23rd, and just multiply the 2 base numbers. That's 12, 2.2, a little bit bigger. Notice it got to 13. All right, that's where we're going to stop here. You'll see that the answer key is probably provided in class, but they're all kind of the same. And if you get the idea, then you can move on to another task. Thank you.